Hello everybody. In this video, we are going to continue solving another problem live from LeetCode's top interview 150 problem list. So far, we have solved all the problems up to find the index of the first occurrence in a string. If you haven't checked out my videos on those problems, please go to my channel and check them out. Okay, the next one is text justification. Okay, it is classified as a hard problem. This will be the third hard problem we'll be doing on this channel. Okay, let's read the problem. Given an array of strings words and a max width, format the text such that each line has exactly max width characters and fully left and right justified. Okay, you should pack your words in a greedy approach. That is, pack as many words as you can in each line. Pad extra spaces when necessary so that each line is exactly maxed with characters. Okay. Extra spaces between words should be distributed as evenly as possible. If the number of spaces on a line does not divide evenly between words, the empty slots on the left will be assigned more spaces than the slots on the right. I see. Okay. So for the last line of text, it should be left justified and no extra spaces inserted between words. Okay. So they have so many, interesting cases. Yeah, we need to make sure we remember each of them. Okay. So, notes are the word is just a character sequence consisting of non-space characters. Each word's length is guaranteed to be greater than 0 and not exceed max width. Basically, no word is bigger than the width available in one line. Basically, the input array words contains at least one word. Okay, so that's fine. Let's look at the example. So example one is this is an example of text justification and the max width is 16. Yeah, so basically I think what they're saying is every line has to have exactly 16 characters, and if that means that we put more spaces in the middle, like for example here and here, then that is what we should do. But it should be left justified and it should be right justified right here. And we need to divide spaces equally, right? So for example, in this case, this 4 plus 2 plus 2, so there are 8 characters in the words. That means we need to stuff 8 spaces in 2 gaps or 2 gaps, right? So here we need to put 4 and here we need to put 4. That will divide it equally. Now this one is 7 plus 2, 9, 9 and 4 is 13. So in this case it's 13. So 16 means there are 3 spaces we need to stuff. But because they don't fit evenly into 2 gaps, we do 1 and 1, but we do the extra space on the left side, starting left side, right? So if there are more than 3 words, if there are like 4 words and they were totaling to, let's say in 16, if they were totaling to like 10, right? Which means that there will be 6 spaces to be distributed among 4 gaps. And so we would actually do first gap will have 2 spaces, the second will have 2 spaces, and then a 1 and a 1, right? So that's what they were saying earlier here, that we need to, if it doesn't divide equally, if the number of spaces on line does not divide evenly between words, the empty slots on the left will be assigned more. Okay. Now they call it slot. I'm calling it gaps. Okay. So these are slots anyway. And then the last line, yeah, I mean, this is interesting, right? The last line does have extra spaces because it has to have exactly 16 characters. But here now, last space at the end is allowed because there is no more words, right? Yeah. So that's a special case. What must be acknowledgement shall be. Okay, so here this is fine. There's 4 and 4, 8 and 2, 10. So 6 spaces to distribute in 2 gaps. Okay, so this is the same example as justification here. Only one word fits here. So we just have to have extra space at the end. Oh, so this is interesting. So here we have one gap, but we didn't put all the spaces in the middle because they said the last line has to be left justified. Yeah, okay. So they have quite a few special cases to handle. So in this case, since it is the last line, we still only keep exactly one space between words, but then we stuff off space at the end to make it 16. Okay. I think that's what they are explaining. Okay, and the last example is, yeah, it's pretty long. I'm not going to read it, but I think we understand it pretty well. And I think even in this case, there is a bunch of extra spaces at the end because it's a single word. Okay, there are a few constraints, but in the interest of time, I'm going to skip them. We'll come back to them if we find something interesting where a constraint might help. Okay, so with that, let's figure out an approach. I mean, it's not a very difficult problem in terms of algorithm, right? It is classified as hard, and I think that's because it's very messy and we need to get a lot of details right, and the code can easily get out of hand. So we will see. Um, so let's say that this is the example. Let's begin with this example here. Okay, and then 1 minute, I'm going to remove a few things just to save some space and I'm also going to create more space here. Okay, so the input word, so let's just call this W for now. Okay, or just words, so let's call it words actually. So this is the input, right? The max width is 16, so let's also take it here, and this is the expected output. All right, 3 lines. First line, all of them contain 16 characters exactly, and so on. Okay, so here, I mean, one thing we could do is we could say, okay, let's go word by word in the words array, right? And see how many we can fit in width 16. So we say, okay, this is 4. So 4 fits in 16, yes. Then this is the second word, so we need to put one space plus that word. So that is 4 plus 3, which is 7, that fits in 16, sure. And then we can say, and we can start putting it, right? So like for example here, one approach is, okay, we say when we looked at the word 0, we said word equal to 0, we said yeah, that fits, so let's just put it in the output line. This is the line so far. When we look at word 1, that also fits in the output line with a space, so we will put it there, right? And then we say word equal to 2, yes, that also fits with a space, so we'll put it there. So yeah, does it fit? Yeah, so 4 plus 3 plus 3, yeah, so that's 10, right? 4 plus 3, 7 plus 3, 10, yes, sir. So that's 10. And now we say, hey, for word equal to 3, okay, wait, that is too long, I think. Yeah, it's 7. So with a space, it will be 8. So 10 plus 8 will become 18. That doesn't fit. And at this point, we can justify this, right? The line is fully done, but it's not fully justified left and right. So, right. So at this point, we can actually go back into what we have written in the line, and we can add extra spaces, right? But we can do the same thing without extra memory, right? In the sense, actually, no, not without extra memory. I mean, without going back in, right? So here, what we had to do is we wrote a bunch of characters into a line with minimum number of spaces in the middle, which is 1, but then we are going to go back and increase spaces, which will push out a lot of the content of the string to the right. So we are doing O of n processing again on that line to kind of push out the characters. So instead of doing that, we could say, okay, we are not going to literally write the content into the line. We are going to keep track of what we can do, how many words we can fit, and then we'll put them all in once we know how many words go in, right? So we say initially, we say, let's say start word is 0. The remaining characters is equal to max width, which is 16, right? And yeah, so that's the initial values. And then we start with word equal to 0, right? So we say, okay, when we are looking at the 0th word, what are we doing? We say, okay, hey, the length of 0th word is 4. That fits in 16. So we keep start word equal to 0 because we can still fit that. And the remaining is now going to be updated to 16 minus 4, which is 12, right? Okay, so we keep going like that. And then we say, okay, now our start word is still 0, remaining was 12 because we updated when W was equal to 0, and then W is 1. Here we say, okay, hey, what is the length of this word plus the space? We need one space, right? And that's 3. And so we say 4 plus 12, remaining 12 minus 3 is possible. That would be 9. So remaining will be equal to 9. And since that is possible, we are going to keep start word equal to 0, right? I'll just switch this because that's easier to think about. There you go. Okay. So now, similarly, we again continue. One sec. We again continue. We say now we are at remaining is 9, and the word is, I'll do until one line, right? So I know this is a bit repetitive, but we should finish one line. So we say word is a 2, yeah, the second word, and that requires 3 more spaces, 3 more characters, 1 space and length of 2. So this remaining will be 6. Start word is still 0, right? Now we come to the interesting part. So now we say start word is 0, remaining is 6, and we are looking at word 3. So what happens here? Well, here when we compute remaining, it will become 6 minus the length of example, which is 7 plus 1, 8, right? Because it needs a space. So it will become 6 minus 8 equal to -2, and we can't do that, right? -2. So we say, okay, at this point we stop, and we have our line. We have the words that we need to put. We need to put words from 0 to 2 because the word 3 did not go into a line and justify it fully, right? Left and right. And we do that and we reset a bunch of things. We say now starting word is the same as W, which was 3, right? Our remaining is now back to 16, and that's pretty much it, right? Yeah, and we continue, right? And now the next one will have those values. If you think about it, just writing one more row here, SW will be 3, remaining is going to be 16 again, and we are going to look at the next word, which is 4, right? Actually, remaining cannot be 16. Remaining has to be 16 minus the length of third word, which is 16 minus 7 equal to 9, right? So sorry about that. So that has to be 9, and so because we did, yeah, there you go. And we continue, right? So that's the algorithm. I mean, it's similar to the previous one, except that instead of literally writing all the words with a single space and then going and adding more spaces, which is not efficient to do, we are basically just doing this trick of keeping indices of start and end words and keep track of, like what we need to add. Okay, now what we need to still figure out is how do we write code to justify stuff, right? So, well, given word start index, so let's say word start, W start and W end index, and these are indices into the words array, and max width. So we are given W start, W end, max width, and I think that's it, right? Let's justify it, or what's the algorithm there? Well, first we need to compute. Okay, so let's say total word chars, right? So total word content. Total word content is the sum of lengths of all words between start, W start, and W end, right? Okay, so that's the total number of characters. Well, how many gaps are there? Or they call it slots. I'm going to call it gaps. So we say total gaps equal to, or just gaps equal to, well, word count minus 1, right? So word count minus 1. If there are 3 words, we have 2 gaps. If there are 2 words, we have 1 gap, and so on. So gaps is equal to 1. Now we know how many gaps. How many spaces are we going to put in there to stuff up? Well, the number of spaces is a maximum width minus the total word content, right? So if we have 16 spaces and all the lengths of all the words we need to put in the line adds up to 10, then it's 16 minus 10, right? So that's the number of spaces. Okay, now that many spaces have to be fit in gaps, number of gaps, right? So then we calculate what is our width, gap width, I guess. Gap width equal to, and that is spaces divided by gaps. Now, of course, this may not always be divisible, right? There could be extra. So what do we need to do is we also need something like extra spaces, and that would be spaces percentage gaps. So basically take the remainder when we divide by gaps. And we need to account for that as well, right? We will keep on adding an extra space until we run, until extra spaces is 0 from left to right. Okay, well, there is one interesting thing to take care of here. If the word count is just 1, and that can happen, sometimes only one word will fit on a line, gaps will be 0. So these division and those operators won't work. So I think here we just need to have special case that if gaps equals 0, then gap width is 0, else gap width is this, right? And similarly here, gaps equals 0, and then 0, else spaces percentage gaps, right? Anyway, those are things that we need to take care of whenever we are doing such things like corner cases. Okay, so with that, then we can write a loop, right? We can go, I'm not going to write it all down in algorithm because I think the code is going to pretty much follow from that. But the idea is we loop through the start word index and the end word index. And for each word, we append the word, and then we append the spaces of the gap width, and then we append the second word, right? And so on and so forth. And we take care of extra spaces when we count how many spaces we're going to stuff it in. Okay. So I think that's going to be our algorithm. This one detects the edges of start word and end word for each line, and this one creates one line at a time, which is fully justified. Okay, even though it seems straightforward, I'm already getting a feeling that this is going to be a lot of interesting corner cases and so on to handle. Because, like, for example, we haven't yet talked about the last line always being left justified, right? But we'll get there. I don't think we need to figure that much detail out before jumping into code. So, okay, let's do this. So I'm wondering whether I should write this helper first to justify or the main code. Let's write the helper. I think it just allows us to write the helper in as elegant a way as possible. Actually, you know what? Let's actually write the main code because I need to know the data structures we are going to use for result and building each line. Okay, so I mean, the result is simple. We gotta return a list of strings, so we have to create a list of string, right? But that is an interface, and in Java, I think array list is a good default, but in this case, I mean, actually, linked list would also work, you know. But anyway, let's start with array list here. This is easy. Now we say, okay, of course, since we are building a string incrementally or a line incrementally, we always want to use a string builder, right? Let's call it line new string builder. And the reason I have it declared initially instead of declaring one new or creating one new string builder for each line is we can reuse the memory for the string builder. Once one line is fully built, we can add it to the list of strings and then we can reuse that. In fact, we can give it initial capacity. I think we can give it initial capacity of maxed width because string builder internally is just created with an array and that can grow. But in this case, we are kind of avoiding any growth code because we know that we'll need exactly maxed width number of characters in a line. Okay, so we can do that. Now what do? We say we need to keep track of a few things, right? We need to keep track of the total word, total word chars. Let's call it total word chars. I called it content or something above, but that is the number of characters inside the words, right? Not counting spaces. We'll have total spaces because we need to figure out like at least one space, right? How many spaces need to go. And that gives us the total content length already, so we don't need that separately. And then I think, oh, we need the start index, start word equal to 0, right? Initially we started 0. The end index will be the loop loop variable, so we don't need that separately. I think that is all we need. Okay, now what do? We iterate through each word, right? I less than words dot length. Sorry, actually it's an array, so just dot length plus I. Okay, and then here, okay, so we are at a specific word. If we need to figure out whether that word fits. Okay, so first we say int what was the total once again current line length, or once again line length, right? Well, the total line length before counting this word would be total word chars because that is keeping track of the total number of characters in words plus total spaces, right? That is the line length already, right? Now, what do we need to append for our own word? Where if we are not the first word, then we need to append a space, right? So let's say space is equal to, well, space is also fine. If I is not equal to start word, then we say 1 else 0, right? I mean, we could have done opposite if equal to start one. Anyway, it doesn't matter. So if it's not the start word, we need a space. And we also, let's just take the length of the ith word in a variable, dot length, right? Okay. So those are all the things that will let us know whether we can line length plus spaces plus W. Okay, so that's the next thing, right? We say int next line length or line length with this word, right? Equal to, or new line length. Let's just call it new line length. New line length equal to line length plus spaces plus W length, right? And if that is the one that we need to check whether it fits, is greater than max width, right? Then we have our special code, right? And in else, let me actually do the easier path first. Else is where the word fits. Then what do? We just say, not line length, but total word chars plus equal to our length, and total spaces plus equal to spaces, right? Yeah, that's all. But here is where the tricky part comes. So here we say we are going to call some helper, right? Which will, okay, so let's first do end index and word end, actually word start and word end, right? Word end, or start word and end word. End word. Well, end word is I minus 1, right? If the ith word doesn't fit, then the end word is I minus 1. Okay, then what do? We call some helper here. So let's say justify words. Okay, let's just call it justify words, right? And we'll have to pass a bunch of things, but let me actually figure that out once we implement it. So we'll pass it the words array, the start index, the end index, and so on, enough information for it to figure everything out, right? But then we reset a bunch of things, right? We say, okay, now start word equal to I, right? Then what else do we reset? We reset the total word chars equal to 0. Sorry, actually total word chars equal to the length of the current word, because that is already something that doesn't fit on the previous line. And total spaces is equal to 0. Equal to 0. Okay. I definitely feel there is a couple of special things that we need to do that are missing, but I think this overall is our idea. Oh yeah, and in this case, once the justify words actually creates a line in the string builder, we pass it. Actually, let's write that first, then we need to add it to the result. So here, just because I don't forget it, let me say add new line to the result. Okay, let's go and implement that helper. Private, well, it's void because we are going to reuse the string builder passed to us, right? Like because like I said, instead of creating a new string builder for every line, it's just a minor or micro optimization of memory to reuse that. Or maybe it's not so minor, right? So justify words. Okay, what do we need? Well, we need words, we need start word, we need end word. Remember, those are inclusive, right? The indices. Actually, there are going to be a few parameters, so let me just take it down here. So those are the three logical ones together, grouped together. Okay, what else do we need? Well, we need the max width, right? That we need to justify in, and we need the total word chars. Well, we could calculate that because we know the start index and end index and can loop through it. But since our caller would have already done that, let's just take it as a parameter to avoid that duplicate calculation, right? And from this, we can figure out like, okay, how many spaces do we need to stuff, right? So I think that's good. And then we need a string builder where we are going to do all this. String builder line, right? I think that must be it. Okay, so let's figure this out. So this is probably the most crucial code of this problem. Okay, so first we figure out how many gaps do we have. And how many gaps do we have is one less than the word count. So end word minus start word. Actually, that is one less than the number of words, right? If end word is 5 and start word is 3, then there are 3 words. And so, but 5 minus 3 will give you 2. So end word minus start word plus 1 would be the word count. Okay. So that is the number of gaps we need. How many spaces do we have to stuff? Well, we have to stuff max width minus total word chars. That's the number of spaces we need to stuff in. No gaps, right? Gaps, number of gaps. Okay, so then what is the gap width? Well, the gap width is like we said, we have a special case, right? Like we said here, yeah, it's right here actually, gap width, right? So if gaps equal 0, then it's 0, else it's spaces divided by gaps, right? I can literally, okay, so that is, and then the benefit of at least spending an extra few minutes in the algorithm, gaps equal 0, then 0, and else spaces percentage gaps, right? Okay, so those are the, okay, I think that's good. And now we just loop, right? We say int I equal to 0, oh sorry, not 0, I equal to start word, I is less or equal to end word, plus I, okay? Those are all the words we need to stuff. Well, what we do is if it is the first word, we don't want to put any spaces before that word, right? But if it is not the first word, so if I is not equal to start word, then we do want to put spaces before we append that word. And so how many spaces do we append? We at least append the gap width number of spaces. So we say line dot append. Actually, you know what? I don't know if string builder has a function to append a character n number of times, but I'm not going to waste time finding it. Our videos become quite long already. So let's say append spaces string builder as p int count, right? I'm going to quickly write it down. For int I equal to 0, I less than count plus I, and I'm just going to say sb dot append space. Okay, so that's our helper to append spaces. Let me call that append spaces. And so what we do is we say line comma how many spaces, gap width number of spaces. Now remember, we may have extra spaces, right? And if we do, we have to append one extra space in each gap. Extra space greater than 0. Then we say append, well, now we can directly append space single and then minus extra spaces, right? Okay, so that's the, if it is not the beginning word. And otherwise, or in all cases rather, not otherwise, we say line dot append words of I, right? Ith word we append. I think that must be it, because are there any cases where is the last word? Well, there is one interesting case, right? And that is like if it was the only word on the line, then it wouldn't be the start word. So we would not append any spaces, but then we wouldn't have, yeah, I think that's a bit tricky. Actually, okay. So here is how we can do that, right? So after the loop ends, we can still just do this, right? We can say append spaces to the line, which is the same as, yeah, we can do max width minus, I don't know why my caps is not working today, minus line dot length. The existing line length, if it is not already max width, we just append spaces to stuff it up at the end. And this will take care of the case where there is only one word and hence we wouldn't have appended spaces after that to make the line that long, right? Okay, I think this is good. I'm just going to move here and take a bit of a leap of faith that works, because it's already become a while. Okay, so let's call this, right? So what do we call it? We call it with words, start word, end word, and we call it with max width, right? Is that the next one? Sorry, 1 second. Yeah, max width and total word chars and the string builder. Total word chars and the string builder, which is line, right? Okay, so we justify that, and once we do that, we say result dot add a line dot to string, right? To string. Okay. You know what? I just realized one issue with this. I mean, not with that line, but with this way of doing it, and I'll tell in a second. But let me make sure there's nothing else here, right? Yeah. Okay. So the issue I'm thinking about is that because we append a line only when we see one more word that doesn't fit, it will never actually have the last line in the answer. Let's run it and see if that is actually a bug. I think it is, but I would just want to try to see it. Well, I'm sure we have to fix a bunch of compile errors first. Max width cannot find symbol. Where is that? Okay, let's do that. Some by some. Well, okay. But if I fix that, are there other cases? I don't know. I'm just going to try to run it to compile it again. Okay, so total word chars. Okay, just some case problems. Yeah, my keyboard shift button is probably not good today. Total word chars is fine here. Oh, it would have highlighted the line. Yeah, there you go. Here. And then that. And then there is, oh, of course, we didn't even return our results. So we say return result. Okay. I'm pretty sure it won't have the last line in. Yeah, okay. So let's see what failed, right? So the first line is there. Oh, wait, what? Ah, I did not reset the string builder. Okay, okay. But as you see, there is no last line. So that is still a bug. So I do need to reset the string builder here, right? So what I do is after I do that, I say line dot, and I do not remember how to reset string builder. 1 second, Java string builder. Let me just quickly look it up. I think there is a dot clear method, maybe. Append capacity. Well, there's no clear. Okay, what is it then? Insert. No, I'm not looking for that. Oh, okay, set length. Okay, so we set the length to 0 and that will clear it. Okay, set length of 0, right? Oh, sorry about that. Okay, now I'm pretty sure still after this we have that bug of last line, and I mean, we just saw it, so we definitely have that bug, but I at least want to make sure every other line is correct. Yeah, so it looks like we are correct except last line. Okay, so yeah, the reason last line doesn't get added is we never execute this loop one more time after the last word. So I mean, what we could do is we could add something at the end of the loop, but one trick we can do is to avoid some code there is here we say less or equal to words.length, right? So let it go one more time, but we want to make sure we don't access anything wrongly. So what we can pretend that if I is equal words.length, we can pretend that there is a very long word there, and that is max width plus one word. Okay, actually just I'm gonna do this and remove that, and then else we say word of I don't know, right? So yeah, I mean, this trick works. I just want to make sure I'm not accessing the word anywhere here. Not really, and here we do I minus one anyway, right? So this actually should fix that bug. Again, I'm just kind of tricking the code into thinking there is one more word, and I don't want that word to fit, right? So I gave it the length. Okay, so first case passed, but we failed the second case. Let's look at that. Oh, this is where, okay, okay. So they want us to always left justify the last line, right? Yeah, I think I thought about this when we were thinking about the algorithm, and then I said, okay, hey, let's think about it later, right? So we need to do that. Because what is happening is for the last line, if there are two words, like here in this case, shall be fits there, and there is needs to be stuffed up a bunch of spaces. Since it is the last line, it cannot be stuffed up in between the words because it has to be, left justified, right? All the words. And so that is tricky. So I think, okay, I think there is a good way to handle this. And I mean, one way to handle this is we could actually just do it here, right? Where we say, hey, if it is the last line, and we can figure that out if the word is the last word, but, or if this line contains the last word, right? But one other way to do it, which I prefer slightly, because the helper then stays a little bit more generic, is that we can actually pass the length to be something different, right? So what I mean is, let's say max line length is equal to, well, in most cases it is equal to max width, right? But in some cases where we are the last line, and that would be when I equal to, I think we added, yeah, words dot length. In that case, we say the last line should only be as big as total word chars plus total spaces. Remember, because that is the minimum, you need that many spaces. And if we have to align that, automatically the logic there would actually, yeah, and then we said total line, sorry, max line length here, right? Yeah, so basically if this is the last line, we say, hey, please justify all the words in as much space as the total length of all the words plus the total spaces needed between those words, which is just counting one space in between, and that will have the desired effect. And wait, okay, so but we need to stuff up at the end with bunch of spaces, don't we? Yeah, so we have to append, because even the last line has trailing spaces, right? So we say append spaces, and then we append to line is a max width minus line dot length, right? Same thing, like we passed it a smaller value, but we want to append that many here. Okay, I mean, this could be max line length as well, line dot length, but uh, let's see if that fixes it. Whoa, okay, I do not know what happened there, my home network or their server. Okay, so that is just some syntax errors. 1 second. I see I do have our brackets in the wrong place. Oh, well, I want this just to make sure, right? So that's the whole expression. Max width minus. Sorry about, I think my keyboard needs to be cleaned. Today there is, yeah, there is some reason shift button is not working very well. Oh, great. So finally it accepted all of that, right? Yeah, so yeah, I kind of suspected it is a hard problem, not because there is a tricky algorithm, but more like there's a lot of tricky cases. Let's actually try to submit this and see how we do compared to everybody else, and also to run a lot more test cases on this one. Oh wow, this is that is very satisfying, and I was not expecting that. Not only we got accepted, we beat everybody in time. Okay, great. Well, we beat about 66.45% in memory, but I think we are quite stingy on memory. We are reusing the string builder and so on. And like I said, when other people also use as good memory as us, then this is quite noisy or not reliable. Okay, hopefully that was very instructive. If you're liking what I'm doing on this channel, please hit the thumbs up button on the video, and please consider subscribing to my channel. See you guys next time.